The goal of this video lesson is to get you to learn how to solve basic trig equations. In the assignment today, they will ask you to solve it on the interval from 0 to 2 pi. And what you need to do is look at your unit circle, right? So for a problem like this, we'll grab our unit circle and we'll have to decide where the sine of x is negative root 3 over 2. And so the sine is negative over here and over here. So we're going to have two answers actually on this interval where the sine is negative root 3 over 2. Now in our long 30, 60, 90 triangle, root 3 over 2 is basically the long leg. So that's going to happen when it's long like this, right? And we have two different little triangles like that. So this is really the angle we're looking for, and this is another angle we're looking for. This angle right here on the interval from 0 to 2 pi is 4 pi over 3. This angle here, the one that goes all the way around to that one, is 5 pi over 3. And so the solution to this equation, sine of x is negative root 3 over 2, is 4 pi over 3 and 5 pi over 3. Things get a little more complicated when you have an equation like this where the cosine or sine or tangent isn't isolated. So the first thing we have to do in this situation is isolate the cosine. So we'll add 1 and divide by 2, and the corresponding equation is cosine of x equals 1/2. This is equivalent, but now that we have it solved for cosine, we can look at our unit circle and decide where is cosine 1/2. Well, cosine is the x-coordinate, and so that's going to happen here and here. Those angles are pi over 3 and 5 pi over 3. So if I'm looking for the solution to this equation on the interval from 0 to 2 pi, my two solutions are pi over 3 and 5 pi over 3. Things get a little trickier when a squared shows up in the problem. And one thing I want you to know is that this right here is equivalent to saying this, sine of x squared. The notation is just that they put the 2 in between the sine and the x, and it's a little cleaner in some situations. Let me get rid of all that if I can. All right. I just figured out how to use the eraser on this thing. All right, so I'm going to solve this for sine squared of x first. So sine squared of x equals 3/4. And now we need to take the square root of both sides. And if I do that, I get sine of x equals the square root of 3/4. And of course, we can't forget our plus or minus in the front of that. And so if I simplify that even further, I get sine of x equals plus or minus square root of 3 over 2. And now the question is, where is the sine square root of 3 over 2? Either positive or negative. And so I'll grab my unit circle and I'll figure that out. And root 3 over 2, remember, is the long leg in our 30, 60, 90. Sine is the y. So we're looking at that angle, that angle, that angle, and that angle. So the answer to this equation actually has four problems, or four answers for this equation. I'm trying to move that up. I guess it's not going to work. But what I need to do then is write down those angle measures, and then all of our four solutions will be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So sometimes with the squared, you get 4 solutions, or definitely more than 2. Finally, I want to do an example with one of the reciprocal functions, and right here we have cosecant of x in the equation. And so I'm going to solve it for cosecant. And you have to realize that cosecant is a reciprocal of the sine function. And so I'm going to take the reciprocal of both sides. Sorry for my bad handwriting. I'm using my finger on an iPad. It's not working very well. And the reciprocal of -1 is still -1, right? And so what we end up with is the sine of x equals -1. And so you need to change these reciprocal functions into the sine, cosine, or tangent function to figure out and solve what they are, because you can see those more easily on the unit circle. And so if I look at my sine of x function, and I'm wondering where sine is -1, well, there's exactly one spot where it's -1. It's down here. And that angle is 3 pi over 2. And so we have one solution to this equation, 3 pi over 2.